We've talked about where the moon may have come from, but what if there was no moon at all? What if you woke up tomorrow and that giant rock 400,000 kilometers away was just gone? The truth is, there'd probably be some pretty major consequences, but the worst of them wouldn't show up overnight. When you think about the moon's effects on Earth, you probably think tides first, and why not? Tides are produced by the gravitational attraction of the moon and the sun, but mostly the moon. The moon is always exerting its gravitational pull on Earth, and our planet can hold on to everything on it except its water. So we get about 2 high tides and 2 low tides every day because of this. Without the moon, the bulge of the Earth's water would still follow the sun, but because it's so far away, tides would only be about 40% as large, and high tide would happen around noon each day. And just imagine the night sky without the moon. Sky watching would be awesomer than ever because there'd never be any moonlight to interfere, but it'd also be dark every night. The full moon is only 1/400,000th as bright as the sun, but that's enough to make a big difference to us and other animals. Moonlight obviously helps nocturnal predators, which have evolved to hunt in low light, but it also helps the prey to detect the animals that are trying to catch them. So without the moon, the food web would be really different really fast. But the moon is responsible for more than just tides and nightlife. Its most important job may actually be stabilizing Earth's axial tilt. Our axial tilt relative to the sun varies between 22.1 and 24.5 degrees, and it's this tilt that gives Earth its seasons. But much like a spinning top, Earth and other planets are susceptible to wobbling as they spin on that axis. Luckily, we have our moon to stabilize any potential fluctuations. Its gravitation helps counteract disturbances caused by nearby planets like Venus and especially Jupiter that would otherwise cause Earth to wobble more than we'd like. Planets without large moons aren't so lucky. Take Mars, which currently has about 24-degree axial tilt. Because Mars only has 2 small moons and, due to the gravitational forces of its neighbors, scientists believe that its tilt has fluctuated between 15 and 35 degrees over time, at one point causing its polar ice to drift all the way to the equator. But thanks to the moon, our axial tilt has stayed consistent for hundreds of millions of years. Without it, we'd be subject to fluctuations even worse than what Mars has seen. Sometimes our tilt would be 0, with Earth standing straight up and down, which would cause an end to the seasons. At other times, the tilt could be 85 degrees. We'd basically be rotating on our side like Uranus does. In which case, each hemisphere would experience nighttime for half the year, plunging it into darkness and cold, while the other 6 months of the year would be constant daylight and temperatures that would put the tropics to shame. But in addition to stabilizing our tilt, the tidal friction caused by the moon also acts as a very slow brake on the Earth's rotation. It's not a huge impact. Our rotation slows about 1 second every 67,000 years. But take the moon away, and things could speed up in a hurry. That's because over 1 billion years ago, before our moon existed, many scientists believe the Earth rotated 3 to 4 times faster than it does now, which means that back then, a day on our planet was only 8 or 9 hours long. The formation of the moon slowly applied a gravitational brake, as it continues to do today. Thanks for joining me for SciShow Space. If you want to learn how you can help us keep exploring the universe together, just go to subbable.com/scishow. And don't forget to go to youtube.com/scishowspace and subscribe.